To do the next step of the CornerStop drawing, it'd be best to show you in video form. I'm going to start with drawing inclined lines or other construction line locations to help us draw those inclined lines, and using different techniques such as polar coordinates or just conveniently using construction lines to assist us. So let's take a look at what we need to draw. 1, 2, 3 angles, a fourth one, and quite a few over here. Let's work with the front view first and take advantage of this measurement of 1, which will also indicate where this corner is going to be. So we can draw this diagonal line first and then transfer it up to the top. Pick the line command, go backwards 1 inch, and then connect it to here. Make that an object line. Then extend an alignment line up from this intersection to the top view so we know where to place this diagonal line at 37 degrees. The other angle at 37 degrees will be directly above this corner. To draw polar coordinates, ortho should be off. Make sure that dynamic input is still on. Pick the line command, start here, and you'll see a length and an angle. Right now, for example, it currently says 41 degrees. The length of this line is going to go probably past 2 inches, so we'll draw a default line length and then trim it back. So I'll type in 2, and I'll hit the tab key on the keyboard to switch to the angle. The angle we need is 37 degrees. Type in 37 and then hit enter. Hit enter to end the command. The line we drew is in this direction. All we would need to do is trim it back. We'll repeat the step for the other one and do just that. Line, intersection, any length, type in 2, tab, 37 degrees, enter, enter again. So there they are. The third line, starting point, is unknown at this time at that corner. We're going to have to locate it here instead, which is known, and work our measurement in another direction, or going from the top right down to the lower left. So we need this corner at 1 1/8. I'll conveniently use the fillet command with the radius of 0 and reconnect these two lines. I'll turn ortho back on so I can draw a line down from this corner 1 1/8. Line, corner, point down, 1 1/8. I'll just draw a little line here so I could see. I'm going to draw a line down this way. The fastest way to do this is just to pick a copy command and copy this from here to there. I already know you know how to copy, so I'm going to show you the polar coordinate method so you understand how to work with angles that are not going up to the right but going down to the left. So type in line, pick this corner, take ortho off, type in a random distance, type in 2, tab. The angle we're going to need is not going to be 37 degrees. Right now, for example, you currently see it's 142. 37 degrees would be from here to here. So we need the difference from the supplementary angle, which is 180 minus 37. As you can see, typing in 37 will not work. It will give us a line going in this direction. We need the angle that's going this way. So we need the angle from the 0 to here. So we need to use the properties of supplementary angles to determine this angle, which would be 143. And then enter to end the command. So we're using a little bit of math. Let's make these become object lines. Remove any line segments we no longer need. Trim off pieces we no longer need. And let's trim this to look like you see here. Okay, so now that it is trimmed, the front view is complete, the top view is complete. Now we're going to take care of the side view. We'll be using the meter box quite extensively. So we're going to have to figure out where these details go. So we're going to have to study the drawing here and here and here to create this right side feature. This line up here refers to this, which refers to this point right here. So we'll transfer this one over first to locate that point. Ortho needs to be back on. I'm still on construction lines. Found my first point right there. That line does go down to a second level. That second level would be right here. And that corner refers to this point right here. Because as you can see, it travels from this direction to here as the object goes in a downward motion. So we're going to transfer from this point over to the second level to find that angle. There it is. I'll just connect it to here. So I have my first point marked. Might as well make that an object line. That leaves one more detail. This second level, this shape you see here, appears right here, and that's what we're going to create. That has to pertain to this sliced segment here for the bottom, and this section up here for that second level. Let's work over the bottom first and indicate where this corner is right here, which would be right there. So, line from this corner happens to be in the same place as this, which is again right there. Looking at a three-dimensional drawing, we're looking for this point, which, if you look at this shape right here, is this shape right here. So this is the corner we want, which is right there. So we're going to draw a line over and down to find that point. Using the meter box again, and here it is, and connect it to there. Make this an object line. Now these meter lines are no longer needed. And it looks like we need to trim a feature away to describe this portion. As so if you study this and this, you'll see right here is right here. This trapezoid shape is right there. This piece in the middle section continues right here. And this opening, or the back I should say, of the object is right there. So our part is complete in the side view as well. Now it's time to dimension the drawing. Now that the dimensioning is almost complete, or as you've been doing this, you might have noticed that using decimal dimensions is sometimes challenging placing them where they need to be. So if you notice in my dimensions, I may have moved them up from their original center points so that they cannot overlap each other. You can do that, of course. Make sure that dimensions from one view do not touch the dimensions of another. That's important. If that does happen, you can move the entire right side view over to the right to give more space. Dimensioning of features typically extends off of one side, as you see here, which is why these three are dimensioned from one corner. Same as you see down here, these three, or these three here. It makes the appearance of the dimensions look nicer. Or these three here. Even though these two objects are the same measurement, they are different features and are both measured. Another option could be to do the following. Take this extension line, connect it to here to represent both locations. Now to dimension angles, use the angular command. To use it, pick 2 lines. Don't pick any corners. Find the angle, place it. If you have an issue with lines or numbers overlapping, you can move those about. Angular, these 2 here. Dimensions should never be within an object, as you see here. So I'm going to take this number and I'm going to move it beneath the object so that the values are not on the drawing itself. We have one more dimension here, which gives us another challenge because that's the wrong value. For example, all of that's 37. That is not the vertex of this line. However, if I pull it here, that will communicate that information. So, complete your dimensioning at this point, and it looks like everything here is good. I don't see anything missing. We got the overall width, height, depth, all the details which are described here for that. Location of all features are described everywhere. So we're going to move on to the next step. We no longer need this meter box, so that'll go away. To prepare the drawing for printing, click on paper space. If you already have a viewport, the drawing may appear automatically. If the viewport is missing, go to the viewport layer, make it current. My message here is to tell me that my layer is frozen. I will need to thaw it first before I can use it. If yours is frozen, that means you already have a viewport. But for example, if there is no viewport, you can make that layer. You can kind of see the orange right there. Make a viewport using the MV command from corner to corner, like you saw in the previous lesson. Now let's scale the drawing. So I type in MS enter, Z enter, E enter to center the drawing, Z enter, 1XP enter to see if the drawing fits at full size. And it does. So I type in PS enter. I'll update my title block and it'll be ready for printing. You might be wondering, why did my line types look thinner than they do here? It's common for that, actually. Now to print to PDF, you should have a PDF option. In my case, I have to use what's called Microsoft XPS Document Writer, which is like a PDF document. Letter, extents, center the plot, 1:1, monochrome, then apply to layout, preview it, and I see my title block is missing. So I will cancel, click on my layers to see what's going on. And I see right there, I turned off a printer. So I turn it back on, go back to print or plot. Everything has been saved, preview it. Now I see everything. Then I'll click on plot and it's going to create a file. Okay, the end of the video.